Very often when we do research or look at research literature, we find that in the literature there is a statement, for example, saying that the two samples were statistically significant different with a p-value of p equals 0.003 or something like that. We very often come across this p-value. Now, what does this actually mean? P-values are very closely linked to the concept of null hypothesis testing. So, null hypothesis testing. Hypothesis testing. And the easiest way to envisage what null hypothesis testing and p-value actually mean is if we just simply look into a different example. For let's say a person is accused of killing their statistics lecturer, and this person is now standing trial for this hideous crime, and there's a jury, and this jury has to make a decision. Is this person guilty or innocent? So that is the decision that the jury has to make in this case. There is nothing in between. The judge will tell the jury that they have to come to an unanimous verdict, and that they can only use the evidence provided. Evidence provided. They cannot look at any other thing. For example, has this person done other things before or things like that? Only the evidence provided is allowed to use. And as in most legal systems it is the case, the starting point will be innocent until proven guilty. So these are the aspects under which the jury has to make a decision, and hopefully they will come to the right conclusion. So what happens then in this process is that evidence will be presented. Evidence will be presented. And on the basis of this evidence, the jury will then say, we have come to this conclusion, beyond reasonable doubt. That the defendant has done the deed or not. Can they be 100% sure? Well, not really. There is a certain element of error, and this usually is indicated by sort of an error margin, or very frequently this is called significance level. And then the jury will present the result and say, we are really, really sure that the defendant has committed the crime and therefore should be sentenced to whatever the crime carries. Now, this is the concept of null hypothesis testing. In this case, the null hypothesis is innocent until proven guilty. So the defendant has not done the deed. This is the null hypothesis. The alternative hypothesis would be the defendant has done the deed. So this would be our null hypothesis, and this is abbreviated with HI. And as I said, we can also formulate an alternative hypothesis where we say the defendant has committed the crime. When we look at data interpretation, we always formulate our null hypothesis and alternative hypothesis first, before we look at the evidence. And then we calculate the evidence, we look at the evidence, we do all the calculations, and we do what is called calculate a test statistic. Calculate test statistics. And depending on what kind of data model we use, we will use different approaches to calculate test statistics. So if we, for example, assume that our data are normally distributed, then we would usually use a normal distribution test statistic or a t-test statistic. And I will discuss the difference in a different video. So we have these test statistics, and now we have collected our evidence, and now we have to make a decision on the basis of our statistics, on our test statistics. And in order to make this decision, we can define what is called a p-value. This p-value is defined as the probability to get the observed statistic or an even more extreme result if we believe the null hypothesis is true. So, for example, we might get a p-value of, let's say, 25%. So it is probable that we get these evidence, that we get these results, and the probability for getting these results is 25%. If the null hypothesis is true, if it is correct. So if we say the null hypothesis is correct and we get the probability for the evidence, for the data with a 25% probability, then we usually would say, yes, this is beyond reasonable doubt, and we are quite happy. It could basically happen if the null hypothesis is true. Very often, or what we usually find, is that this phrase of beyond reasonable doubt, so beyond reasonable doubt, this significance level, and very often it's abbreviated with alpha, is very often set to 5%. In other words, it means that if we get a probability that we get the observed result, for getting the observed result, or one that is more extreme than that, for getting observed result is smaller than 5%, then we would say, actually, this doesn't really make sense. So therefore, we believe that the null hypothesis is not true. In other words, it is very unlikely to get the observed result if the null hypothesis was true. That is basically what this statement here says. It's unlikely to get the observed result. It's unlikely to see that the person, to gather the evidence, if we assume that the null hypothesis is true. That's why we can say if the p-value is smaller than our predefined alpha, the significance level, that's the beyond the reasonable doubt, if the p-value is smaller than the significance level alpha, we would reject, or we would fail to accept the null hypothesis. The p-value is just simply a decision-making tool. Is the evidence strong enough to convict the defendant or not? Is the evidence, are the data strong enough to say that our null hypothesis is true, to accept the null hypothesis, or should we rather accept the alternative hypothesis? So the p-value is only a decision tool, and we can only use the evidence that are provided in our data. Now, when people say, well, we've got a p-value is close to alpha. P-value is close to alpha. So let's say p equals 0.045, alpha equals 0.05, so that's 5%. So we see p-value is close to. Very often people say, well, we need more data. Actually, this is a fallacy in this case, because the p-value is a decision tool to say, is the evidence that we are given by our samples, by our data, is the evidence strong enough to accept or not accept the null hypothesis? In this case, it is p is lower than alpha, and therefore our null hypothesis is not accepted. More data is like saying we need more evidence, but we don't have more evidence. So in a way, null hypothesis testing only relies on the evidence of the samples. So when in some research journals it is said the p-value are close to the alpha, and therefore more data need to be measured, this is nonsense, because the p-value is only a decision tool for this particular set of data, nothing else. If we get a different set of data, we would probably end up with a very different p-value, which again would allow us to make a decision whether we should accept guilty or not guilty, whether we should accept the null hypothesis or not accept the null hypothesis. So I hope this makes sense, and thank you very much for watching.